Hello. In this video, I will show you how to use the Clear SCADA SCADAPack Modbus driver to communicate with the SCADAPack RTU. To start, ensure that you have your Clear SCADA database running, Vuex open, and you are logged into the system. Communicating with the SCADAPack requires a number of objects to be created in the database. Let's begin by creating a folder to hold our configuration. We'll call this folder SCADAPack Tutorial. The first object to create is a SCADAPack Modbus direct channel. The channel object relates to the communications mechanisms used by Clear SCADA to communicate with the device. For example, this may tell Clear SCADA to use a serial connection or connect via UDP or TCP. Double-click on the channel to open the Properties form. On the Channel tab, tick the In-Service box to make the channel active. On the Connection tab, set the connection type to Network. Then on the Modbus tab, set the protocol type to TCP. This tells Clear SCADA to use the Modbus TCP protocol rather than Modbus RTU or ASCII. Finally, on the Scan Parameters tab, set the line speed to 102.4.000. This allows Clear SCADA to calculate expected message transmissions times for timeout calculations. Save and close the form. The next object we need to create is called an outstation set. This defines a group of RTUs or outstations as we call them in Clear SCADA. Create a SCADAPack Modbus direct outstation set in the SCADAPack tutorial group. Open the Properties form, put the set in service, and tie it to the channel we created. Save the form and close it. Finally, to establish comms to the SCADAPack, we need an outstation object. So let's create a SCADAPack Modbus SCADAPack direct outstation object in the SCADAPack tutorial group. Open the Properties form and start with the Outstation tab. Put the outstation in service. This will allow Clear SCADA to attempt to communicate with the device. Tie the outstation to the outstation set, which is in turn tied to the comms channel. Go to the SCADAPack tab. Set the address field to 1. This is the Modbus address of the SCADAPack device. Set the firmware type to match the type of firmware running in your SCADAPack. In my case, I'm running the Isograph firmware. Note the times for retrieval interval 3, a 2-second normal poll and a 1-second promoted poll. On the Direct tab, tick the Promote when displaying points option. With this configuration, data configured in retrieval interval 3 will be polled from the SCADAPack every 2 seconds. When a mimic is on display in Clear SCADA that contains points from this outstation, the promoted poll rates will then be used. Lastly, go to the Network tab. Configure a single network, enter the IP address of the SCADAPack, and enter port number 502. Save the form, and that's all that's needed to establish comms. We can see if we were successful by looking at the status dialog for the outstation object. Right-click on the outstation object in the database tree, and select View Status. Note that the state field says Healthy Multidrop. This tells us that Clear SCADA is successfully communicating with the device. Also notice here the value of the controller type field. Clear SCADA has communicated with the device and tells us that the RTU is a SCADAPack 32 running Isograph firmware. It also tells us the firmware versions in the device. Finally, we add some point objects to retrieve data from the device from the available inputs to my RTU. So let's configure the points. Create a SCADAPack Modbus analog input point in the SCADAPack tutorial folder and call it AI1. Open the Properties form, put the point in service, and tie it to our outstation object. Set the point address to be 30,002. Set the retrieval interval to be interval 3. We want to take our 0 to 32,767 input and scale this to 0 to 100%. On the Analog Point tab, note that the 0 scale and full scale are already 0 and 100. Now we just need to set the raw values. So scroll down to the Scaling section, ensure scaling is enabled, and note that the default value is already 32,767, so we don't need to change this. Set the units to %. On the Historic tab, enable historic logging by ticking Enabled. Set the offset to h-1h and the interval to 2h. This will default the trend time span to start from the beginning of the last hour with a span of 2 hours. Finally, tick the Use Raw Data box at the bottom. This tells Clear SCADA to display trends using the raw samples rather than processing prior to sending to the client. Save and close the form. We can check that the value is updating by checking the View Status dialog for the point. You can see the point value updating as we click the Refresh button. Now create a SCADAPack Modbus digital input point and call it DI1. Again, put the point in service and tie it to our outstation object. Set the point address this time to be 10,001. Set the retrieval interval to be interval 2. Now we want an alarm to be raised when the digital input is true, so we can enable the on state to be a high severity alarm. We'll also configure the point state descriptions so users see a meaningful description of the point state. Set the 0 state to normal and the 1 state to fault. On the Historic tab, enable Historic Logging. Set the offset to H-1H and the interval to 2H, and tick the Use Raw Data box at the bottom. We are now complete, so save the form and close it. Again, we can check the updates using the View Status dialog as I toggle the state of the digital input on my RTU, and this time note that the values are updating more quickly as we are using a 1-second normal pole rather than the 2 seconds used for our analog point. Finally, we can add these points to a mimic to more easily view the data. Open the default mimic in design mode. Drag on the AI1 point and show its name. Also show its formatted value and its last updated timestamp. Then we do the same for the DI1 point, only this time we will show the state property as a text description rather than a value. Lastly, we drag on the outstation object to show its status by selecting the state option. Save the mimic and then put it in run mode. Open the historic trend for AI1. You can see that as I change the analog input, new values are added to the trend. Open the trend for DI1, and you'll notice that only the state transitions are recorded in the historian. The historian typically logs on state change, and so if the point value has not changed, Clear SCADA saves disk space by not recording unnecessary data. There's no point in logging the value every 1 second when it's not changing. Before we finish, let's have a look at what happens when communications is lost to the device. Unplug the comms cable from the RTU. After some time, Clear SCADA will raise a communications failed alarm. The time to raise this alarm depends on how frequently you poll the device, the comms retries configured, the number of transaction attempts, and the way that failures occur. All these settings are configurable to provide flexibility in the way that comms problems are reported to users. Note the comms failure alarm in the alarm banner and on the mimic. The points now show as purple. This value indicates bad quality, and we can see from the View Status dialog that the quality is last known value. After a short period, we plug the comms cable back in. Clear SCADA will re-establish communications with the SCADAPack and resume polling of the device. This brings us to the end of our SCADAPack tutorial. This is a very simple introduction to the SCADAPack Modbus driver in Clear SCADA. However, Clear SCADA provides a number of advanced tools to extend upon the standard Modbus functionality. Features such as built-in real flow support for communicating with gas flow computers, unsolicited PLC for inbound messages, advanced comm support for dual paths, backup dial-up links, and advanced communication diagnostics, combined with standard Clear SCADA features such as templates and instances, positions Clear SCADA as a leading product for SCADA and wide area telemetry systems. Thank you.